Good afternoon, class. We are looking at Algebra Practice 3, Module 3, covering Chapters 7 and 8. Chapter 7, Rational Expressions and Equations. Chapter 8, Roots, Radicals, and Complex Numbers. First question, we want to find all values for which the function is 0, and in part B, what makes it undefined. In general, when you deal with a fractional expression, it is 0 when the top is 0. Top is x plus 1. You set it equal to 0. The answer is negative 1. A fractional expression is undefined when the denominator is 0. So you set the denominator equal to 0. X squared becomes 49, and x becomes plus minus 7. We want to simplify the expression. The denominator is in the form of a squared minus b squared. We factor the bottom into x plus 6, x minus 6. And here's the final answer. In order to add, we should always come up with LCD. If the denominators are opposites, you keep one of them as the least common denominator. So if we keep x minus 5 as the common denominator, it's important to know this is the same as minus 1 over x minus 5. Therefore, the answer becomes 0. So when the denominators are opposites, just keep one of them as the LCD. We want to find the least common denominator, LCD. Between 4 and 6, we end up with 12. This is x squared. This is x to the power of 6. The one with the larger exponent, this is y. This is y to the power of 5. We keep y to the power of 5. So that's the LCD for both. And we have to raise each fraction such that this would be the LCD. So if you look at the first one, how do you raise it to get here? That means you're going to divide the LCD by the first denominator. When you divide, you end up with 3x to the power of 4. For the second one, if you divide, you end up with 2y to the power of 4. So the first one, you raise it by 3x to the power of 4. That means you multiply it by the top as well as the bottom. And the second one by 2y to the power of 4. So the denominator in both cases, notice, becomes this LCD. Now these two, when we multiply, we get 3x to the power of 4. Over here, we get 22y to the power of 4. To simplify this, we need to factor each and every one of them, starting with the first fraction. The top has to be factored out, and so the bottom. We've gone over the factoring when a is not 1. Since 5 is a prime number, it's just 1 and 5. And since 2 is a prime number, it's just 1 and 2. That makes it fairly easy. Pay attention to the fact that this is 4. So it's 1 and 4 or 2 and 2. Somehow we got to get the middle term of 12x. Notice 10x and 2x, they add up to 12x. 3 is a prime number. That's also easy. 1 and 3, because this is positive, both positive or both negative. Remember, adding up these two, we must end up with 5x. Now, the next thing is important. You have a division. That means you're going to divide by this, and therefore you need to flip this over. So the very first thing is to flip this over, and when you do that, this comes up. And you factor it. Again, 2 is a prime number, 1 and 2. you pay attention to how to get to 11x. So 8x and 3x is 11x. The top 3x squared plus 7x plus 2 goes down, becomes x plus 2 times 3x plus 1. Finally, you factor the last piece in the same manner. 3 is a prime number, 1 and 3. This is 1, so it's just 1 and 1, or negative 1 and negative 1, whatever that works. 5 is 1 and 5. 8 is 1 and 8, or 2 times 4. 4 and 2 in this manner works because this is 20x, this is 2x, giving you 22x. And you may notice that x plus 2 cancels out x plus 2. 5x plus 2 cancels out 5x plus 2. X plus 4 cancels out x plus 4. 2x plus 3 cancels out 2x plus 3. X plus 1 cancels out x plus 1. 3x plus 1 cancels out 3x plus 1. There is nothing left, which means 1 over 1. In other words, everything in the top and the bottom, they cancel each other. And again, just as an example, you can just do this, and then you take it from there. Or for example, 5x plus 2, I put it with an x. And you continue working on the rest. Here's the next one. We need to factor this expression. The top is in the form of a squared minus b squared. So you get r plus 3 times r minus 3. The denominator is in the form of a cubed minus b cubed, where a is r and b is 3. So you have r minus 3, a minus b. Let me go with a minus b, explain that one, and a general form, a minus b, b squared plus ab plus b squared, which gives you r minus 3, r squared plus 3r plus 9. We see a division, we flip it over, the bottom goes up, and that's a prime polynomial. The top comes down, and this is in the form of a plus b quantity squared, which is a squared plus 2ab plus b squared. Notice we can drop those two. These two are identical, we can drop them. Finally, I can drop this and replace it with 1, and I can drop the exponent. Here's the final answer. As you can see, lots of factoring is involved, so we should be very comfortable with factoring. It becomes a piece of cake. We want to add up, we need to come up with LCD. Therefore, the first denominator has to be factored out into x minus 4 times x minus 6, because we want two numbers. The product is 24, the sum is negative 10. Now, notice we can use this as a common denominator or LCD, because it's x minus 4 times x minus 6. Remember, 6 minus x and x minus 6, they're opposite. So this piece is the same as minus 3 over x minus 6. So the first numerator doesn't change. This one is minus 3 times x minus 4, and plus 1 has no denominator. You have to multiply by both factors. We are going to distribute x minus 3x plus 12 plus, now this one, you remember is x squared minus 10x plus 24. So we want to put this in descending order and factor if we can. So we have x squared. Let's combine the others that we can. For example, we have x and negative 3x is negative 2x with negative 10x. They give us negative 12x. This is 12. This is 24. They add up to 36. So the top is in the form of a squared minus 2ab plus b squared, which is a minus b squared. So it's x minus 6 quantity squared. This cancels out the exponent here, and here's your final answer. It's all about factoring. We want to add them up. We do the same thing. Every denominator must be factored out. So it's only the first one that we need to factor it into a minus 2, a plus 2. And therefore, that becomes a common denominator or LCD. So the first fraction doesn't change. Plus the second one, you see a minus 2, a plus 2 is missing. So 1 times a minus 2. 1 times a plus 2. For the second one, a plus 2, so a minus 2 is missing, a times a minus 2. So let's pay attention to this one more time. Here's the first one. You keep it unchanged because the denominator of a squared minus 4 is the same as the factored form a minus 2 times a plus 2. This one, when you divide this by this, you notice a plus 2 is missing. So the top times a plus 2, in this case, a minus 2 is missing. Now let's distribute. So this is a minus 2. This is plus a plus 2. And this gives us a squared minus 2a. So we have a plus a minus 2a. And they cancel each other. Minus 2, positive 2 cancel each other. Numerator is left with a squared only. A squared only. And of course, it can't be simplified any further. We are done. What we are looking at is called a complex fraction. Which means a fraction within a fraction. The fastest way is to multiply the top and the bottom by LCD of all those fractions. Notice there's 1, 2, 3, 4 fractions, all of which have the LCD of x times y. Let's multiply every term by x times y. So that means multiply this one. When you do that, x goes away, you get 2y. Multiply this one, y goes away, you get 2x. That's the top. The bottom, y goes away, you get x squared. And the last piece, x goes away, you get minus y squared. So I hope you can see how we can go from a complex fraction to a simple fraction. We factor the 2 out from the numerator, and the bottom is a squared minus b squared, so x plus y, x minus y. Please notice y plus x and x plus y are the same. It's not x minus y and y minus x that they are opposites. They are the same. Therefore, the answer is 2 over x minus y. Next, we want to solve for a specific variable. We are dealing with a bunch of fractions. Again, the best course of action to get rid of them. And to do that, we're going to multiply both sides by LCD, which is P times Q times F. What it means is that we multiply every piece by PQF. So if you multiply the first one, P goes away. You get QF. If you multiply it by the second one, Q goes away, PF. And the right side, F goes away, PQ. That's what you get. Now, as you can see, there is no more denominators. We are solving for Q. Therefore, we are bringing all the Q's together. This one can be moved to the right because that's the least number of steps, although I can bring this one to the left and this one to the right. Now, in this case, we can take out the Q. And since we are solving for Q, we're going to get rid of P minus F by dividing both sides by it. And as you can see, if you're solving for Q, the result on the other side cannot have any Q's. We want to solve this equation. Again, the best course of action to get rid of all the fractions. As you can see, the LCD is 4. If I multiply it by the first one, 4 cancels out the 2. 2 times 3x is 6x. Minus 4 cancels out the second one, simply x minus 1. And the right side is just 4. Don't forget to keep this negative sign because it's going to distribute, giving us minus x plus 1. So they add up to 5x. And we are going to subtract the 1. We get 5x equals 3. Divide by 5. There you have it. The final answer, x equals 3/5. Here's the next question. We do the same thing. We want to multiply both sides by LCD. We need to factor everything out. So x squared minus 1 is the product of x minus 1 and x plus 1. So as you can see, the common denominator is this thing times 2. So let's multiply everything by that. And the difference between 9 and 10 is that the 9 didn't have any variable in the denominator, but 10 does. None of the denominators can be 0. So you have to set this equal to 0 and exclude that. X equals 1, x equals negative 1, they're out. This covers that. So we would do this. We're going to multiply by LCD, which is this piece. And we're going to say x can't be positive negative 1. This is extremely important. When we multiply this by the first one, I hope you realize x squared minus 1 is the same as x minus 1 and x plus 1. Therefore, this goes away. You have 2 times 2, which is 4. When you multiply it by the second piece, 2 goes away minus 1 times this product, which is obviously x squared minus 1. Remember, we know this product is x squared minus 1. The right side, x minus 1 goes away. So you have 1 times 2 times x plus 1. This is what we have. We are going to distribute the negative 1 as well as 2 here. This gives us 4 minus x squared plus 1. This gives us 2x plus 2. Now we want to bring everything to the same side, and this becomes a quadratic equation we want to solve. First, notice we have 5 minus x squared on the left. If we bring it this way, minus x squared becomes positive x squared, and positive 5 becomes negative 5. If we put it in descending order, we have x squared plus 2x, 2 and negative 5, they add up to negative 3. This is an easy factor. We want two numbers, the product is negative 3 and the sum is positive 2. Therefore, we have x plus 3 times x minus 1. This gives us x equals negative 3. This gives us x equals 1. Now it's a good time to check. Here's how you check it. X can't be 1, x can't be negative 1, so this is out. So checking is extremely important when you deal with rational equations. Jeff can mow a grass in 5 hours. Mark can do the same job in 10 hours. How long will it take him to do the job together? This is a class of problem known as work problem. When people put their efforts together. So you have to set up a table anytime you have a word problem. That's a good practice. If you take a look at this one, Jeff can do the job in 5 hours. Mark can do it in 10 hours. If the units are not the same, you make it so. How long does it take them to work together? We have no idea. How about X hours? Now, what is the rate? I'm going to define the rate in this case so everybody's clear. Rate is defined as portion or fraction of the job done in 1 unit of time. And I say 1 unit because it may be minutes, hours, months, whatever the units are. So if Jeff can do the job in 5 hours, that means in 1 hour, he can do 1/5, Mark can do 1/10, and together 1/x. So this is the concept of a rate. So in 1 hour, 1 unit of time, we can add them up, and this is 1 unit of time for Jeff, 1 unit of time for Mark, portion of a job. And in 1 unit of time, portion of a job, so they add up to 1/x. Look at the second column. The reason we add them up, because they are working together. Here's their efforts over the course of 1 unit of time. Now, we're going to multiply both sides by LCD, which is 10x. Needless to say, x can't be 0. When you multiply by the first one, you get 2x. The second one gives you x, and the right side gives you 10. Therefore, we have 3x equals 10, and x equals 10/3. Now, the reason I change it to a mixed number, because I want this to be clear for the reader that the amount of time it takes for both of them to do the job, it's a little bit more than 3. So when you go back and look at the numbers, if Jeff can do it in 5, Mark can do it in 10, together must be less than the smaller of the two numbers. So must be less than 5, so it makes sense. In fact, if they do the job in the same amount of time, it will be cut in half. For example, if Jeff can do it in 8 hours, Mark can do it in 8. When they both work together, it will be done in 4 hours. At a dairy plant, a milk tank can be filled in 6 hours using inlet valve. Using the outlet valve, the tank can be emptied in 8 hours if both are open and milk is being pumped into the tank. How long will it take them to fill the tank? We're going to come up with the same type of table. So first valve, the inlet does the job in 6 hours. The outlet does the job in 8 hours. Working together, it takes how long we don't know, let's say X. The rate for each case is the reciprocal. So this is 1/6, this is 1/8, this is 1/x. Now, what's interesting here is, in this case, the inlet is adding milk, but the outlet is taking out. Therefore, they are working against each other. Instead of saying 1/6 plus 1/8, you have to say 1/6 minus 1/8. So pay attention to this and why we are using negative. They are working against each other. Clearly, 24x is the LCD. If you multiply it by the first number, you get 4x minus second number gives you 3x, and the right side is 24. And x becomes 24 hours. Now, again, pay attention to see if it intuitively makes sense. If it takes 6 hours to fill it up and 8 hours to empty it, and they're working against each other, it should take a very long time to fill it up, and it makes sense. This number should be much larger than the two of them. Two vehicles, a car and a truck, leave an intersection at the same time. Headed for the same destination, the car averages 60 miles per hour and the truck averages 80 miles per hour. If the truck arrives 2 hours ahead of the car, find the distance between the 2 points. This is a class of problem known as motion problem, in which case D equals R times T. D is the distance, R is the rate or average speed, T is the time. Therefore, we have to make up a table like this. R times T is D. The car is doing 60 miles per hour. The truck is doing 80 miles per hour. So simply put, fill them up. Now we're going to look at the time, and the time is obviously the one that is going faster is going to get sooner. That's why the truck arrives 2 hours ahead. So if it takes the truck X amount of time, it takes the car the same plus 2. So if this is X hours, so it's important that you put the units. If you want, just add hours here so you know, or you can even put it here. This is MPH, this is hours, and this is miles. If you choose X to represent the amount of time for the car, then for the truck would be X minus. Their product is the same as the distance. So the distance the car covers is 60 times X plus 2, and the truck covers 80X, because they both go from point A to point B, the two must be identical. We set them equal, we distribute, and this becomes 60X plus 120. We are going to subtract 60X from both sides. We get 20X equals 120, and X becomes 6 hours. Now, it's extremely important to see that what the question was asking. The question is asking for the distance, everybody, not the time. What does it mean? We are not finished. So if X is 6, that means X plus 2 is 8, and the distance is the product of the two, and I would highly recommend you do both of them. In other words, 6 times 80, 8 times 60, and they both give us the same answer. This is how you check it. The distance is 480 miles, and you must check by multiplying these two numbers as well. So 6 hours for truck, 8 hours for the car. I can even put that in. The sum of the reciprocals of two consecutive integers is 15 over 56. We want to find the two integers. First, as far as the integers are concerned, class, the integers are set of numbers as such: 1, 2, 0, 1, 2, 3 to infinity, -1, -2 to -infinity. And when we say consecutive. So if the first one is x, then the next one must be x plus 1, the next one must be x plus 2, so on and so forth. It's important, sometimes they mention two odd consecutive or even consecutive, in which case the difference is 2. Instead of x and x plus 1, we would have x and x plus 2. But this is simply consecutive, and the reciprocal of this one is 1 over x, this one is 1 over x plus 1. They add up to the number given. We multiply both sides by LCD, which is simply the product of all those three. So the first one, the first fraction, when we multiply it, x goes away. So 56 times x plus 1. The second one, x plus 1 goes away. That means 56 times x. And the right side, just 56 goes away, which is 15 times x plus 1. As you can see, we no longer have any fractions. We distribute, we get 56x plus 56 plus 56x. On the right side, we get 15x squared plus 15x. It's 112x. We subtract it from the other side. And we get 15x squared minus 97x minus 56. Why are we doing that? So we bring it to the same side, we can factor and solve. When we factor, we end up with the following. This is negative 105x. This is 8x. They add up to negative 97x. In other words, it works. There are two answers. X is either 7 or negative 8 over 15. Look at the integers. This is not an integer. That's not an acceptable answer. So if x is 7, then x plus 1 must be 8. X equals 7, x plus 1 equals 8. Those are the two numbers.